So as we finish this up, you'll remember that there are things that work in right triangles that don't work in oblique triangles anymore. So let me give you one example. In a right triangle, the Pythagorean theorem works. All right, we know that a squared plus b squared equals c squared. In an oblique triangle, that doesn't work anymore. And what we had to learn was the law of cosines instead. The law of cosines, if you cross-multiply the law of cosines, you get something that looks a lot like the Pythagorean theorem. So in an oblique triangle, it is a squared plus b squared equals c squared. But because it's oblique, there's more added on the end. And it was 2ab cos c. All right, that was the law of cosines. That's the cross-multiplied format of the law of cosines. It's still the law of cosines. It's just already been cross-multiplied. So you can see it starts out a squared plus b squared equals c squared, but because it's oblique, you got to fix the part of the triangle that's not a right triangle anymore. So the same idea is true for area. So I want to review with you, let's see if you remember, how do you find the area of a right triangle? You guys remember the formula for area of a triangle, as long as it has a right angle? Anybody have it? What's the area of a rectangle? Yeah, or a times b, like a times b, right? For a rectangle, what's a triangle then? 1/2. All right, so a right triangle is a equals 1/2 ab. An oblique triangle starts out the same, but you have to modify it because it's oblique, because we don't have a right triangle anymore. And so in an oblique triangle, the formula becomes, and this is all because it doesn't have a right angle, 1/2 ab sine c. That is the area for an oblique triangle. So you've got the area for a right triangle and you have the area of an oblique triangle. Now you could vary that a little bit. It doesn't have to be little a, little b. It could be little b, little c. But if it was, what do you think the sine angle would be? Capital A. Exactly. And then if you had little a, little c, then the sine angle would be b. So you can vary it depending on which side you have, but those are the formulas that work for an oblique triangle. So let's just practice that. It's not terribly hard. So find the area. Triangle with b, little b is 112, little c 52, all right, if we're finding area and we have little b and little c, what would be the best angle for us to have right now? A, that would be the best. Okay, but I'm not going to give you that one. I'm going to give you this one instead. All right, so we need to find the area. In order to find the area, we need we need A first. So we need to find A before we can find area, because the formula requires A, not B. So you'll still set up your 6 parts of an oblique triangle: 102, 112, and 52. The way I've set it up, I noticed right away I've got this pair So what law will I use first? Okay, law of sines. So we'll have set up 112 over the sine of 102 equals 52 over the sine of c. Then just like on your little open quiz you just did right now, you'll cross multiply and you'll end up dividing. So c will end up to be the result of sine inverse of the cross multiplied 52 sine 102 divided by 112. And I think, yeah, and in my notes I worked that out, and that works out to be 27 degrees. So we can go back to our set of 6, and we know that we have 27. And once we have the 27, we can use the rule of 180 to find A. So A turns out to be 51. Now that we have A, we can find area using the new area formula we just learned today. So the area formula for this oblique triangle will be 1/2 BC sine A. So 1/2, B is 112, C is 52, and the sine of A, which worked out to be 51 degrees. And then you just type that straight in your calculator, one big multiplication problem, 0.5 times 112 times 52 times sine 51, just type it straight in, and you get 2263 square units as your area for that oblique triangle. Okay, before I go on to example 2, are there any questions on that? Yeah.
So you don't want to round or anything?
It'll tell, yeah, I don't remember what the decimal was on that. You want to tell me?
Oh, it was 0.04. I was just asking.
Yeah, you usually say whole unit.
Okay.
So. Okay, let's try another one. All right, find the area of a decagon inscribed in a circle of radius 14. We talked a little bit about this before, 14 centimeters, kind of what this idea is. Okay, getting a circle and a decagon. All right, so let's talk about the word deca. Okay, it's similar to our word decade. So how many sides does a decagon have? Okay, it has 10 total sides. All right, so we've got a circle. I can't do that nice, hold it and have it form nicely for me in the app I'm in right now. But you've got your circle. Okay, if I know the radius of that circle is 14, then if I draw a line through the center, both sides of that are going to be 14 according to what radiuses are. And then a decagon, because there will be 10 sides, 5 of them will be on the top and 5 of them will be on the bottom. So it'll be something like this. All right, there's 10. And to draw the decagon, I'm going to connect all of these edges, all the vertices. Okay, the vertex ends, that will be my decagon. And I'm trying to find the area of this decagon shape. So one full decagon is made up of how many smaller parts? 10 what? 10 triangles. Okay, there are 10 mini triangles that make up one full decagon. All right, so we get that first. We understand that. So decagon equals 10 triangles. So if I can find one of the triangles using my new formula, then all I got to do is multiply it by 10 to figure out how much area there is. So let's just focus on one of the triangles. I'm going to pick this particular triangle right here. Okay, this is going to be the triangle I'm going to focus on. Okay, so that'll be my one representative triangle. All right, well, I labeled one of the sides as 14. I know that this side is going to be 14 also, so I've got two sides that are called 14. I just need to figure out the central angle. And remember, we talked about a circle all the way around is 360 degrees. And if I've got 360 degrees divided up into 10 chunks, how much is each triangle worth in terms of degrees? Yeah, 36. And so we've got 36 degrees as the value of the inside angle, the one that's closest to the center. So that'll be 36. So I should be able to find the area of that. So let's call the center C. So I'll label that as C, and then my other edges we'll just call A and B. So in this triangle now that I've set up, I can set up my A, B, C. C I knew to be 36 degrees. And then little a, little b, little c, I know that little a and little b are both 14. And that's set up now perfectly for me to do area, because area doesn't need a pair. Area needs one of each, or like one of everything. It's got one A, one B, and one capital C, and that's perfect for area. And so my area will be, according to the formula, 1/2 the A part, the B part, and the sine of the C part. So this would give me 1/2. A is 14, the other B is also 14, and then the sine of 36 degrees. And then again, you just let your calculator do the work on that. And you'll get area to have a value of 57.603. And we knew the radius was measured in centimeters. And so area is always square something, and so it'll be square centimeters, or you could write centimeters with a little square sign on it if you want. Okay, any questions on that one? Yeah. Oh, we haven't multiplied by 10 yet. Yes, thank you. That's the area of a triangle. So the decagon would be that multiplied by 10. So 576.03 square centimeters. Thanks. Okay, great. So we've learned about area using 1/2 AB sine C or 1/2 of any combination. There's one other way to find area. So this way of finding area is dependent on us knowing an angle. We have to know an angle in order to figure out the area. So then that would lead to our last question of the day, which would be, what if it's impossible to find an angle? What if you don't know an angle? Can you still find the area of the triangle? And the answer to that is yes. So this Greek mathematician named Hieron was, it's like hero with an N. He was a student of Pythagoras. Pythagoras was his teacher. And so we know Pythagoras was really good at geometry, and so his students also became really good at geometry. So Hieron came up with another formula for how to find area of a triangle. So this is called Hieron formula. Okay, Hieron used the letter P to stand for the perimeter. And the perimeter is all the sides added up. He used the letter S to stand for something called the semi-perimeter. Or semi-perimeter means half perimeter. if you have a triangle and you know all the sides, but you don't know any of the angles. Well, if you know all the sides, you can find the perimeter. You just add up all the sides. That would be A plus B plus C. So maybe we want to write that down as what the perimeter is, A plus B plus C, so add them up. And then divide it by 2 to get the semi-perimeter. Once you do that, here's his area formula. He said, once you figure out what S is, first figure out P, which is the perimeter, then figure out S, which is the semi-perimeter. And once you know what S is, take that S and times it by S minus the A side. And once you get that times S minus the B side. And once you get that, multiply that by S minus the C side. And once you've done all that, square root the whole thing, and that will give you the exact area of a triangle. There's a big long proof for how this works. It would take pages and pages and pages of geometry for us to prove it. So I'm just going to tell you that he figured it out and that it works all the time. Okay? If you ever, when I was in my master's program, I had to learn how to prove this. This is not something you ever need to do, but you can just believe me that that is true. All right, so let's practice it and see that it works. So we'll use this when we don't have an angle. So if you have an angle, use the other one, 1/2 AB sine C, if you have an angle. If you don't, then you're going to use Huron. So find area using Huron for the following triangle. A equals 43, B equals 53, C equals 72. So we do not have an angle. And we can't use the law of sines or the law of cosines to help us figure out an angle. Well, we could, but that'd be way more work. We don't need to. We can use Huron. It's a lot easier. So first you want to find the perimeter. So the perimeter will just be 43 plus 53 plus 72. So you just add up those three things to find your perimeter. That gives you 168. Then you find the semi-perimeter, which is half of that. So 168 divided by 2, that's 84. And then you set up the area. And the area will start with the number 84 under a square root. And then you do 84 minus 43, which is the A term. And 84 minus 53, which is the B term. And 84 minus 72. And you could just type that all into your calculator. Just use parentheses. Make sure you always put a parenthesis around every subtraction part. As long as you're careful, you don't make a mistake in how you put your parentheses, you should get the same answer as me.